Welcome to Data Structure and Algorithms tutorial series. Today we are going to talk about the stack abstract data type definition and applications in real life. First we are going to talk about the stack definition. So what is a stack? A stack is an ordered collection of items in which insertion and deletion are done at one end, called the top. The last element inserted is the first one to be deleted, hence it is called the last and first out, LIFO, list. Stack main operations are push and pop. The push operation inserts new element at the top of the stack, whereas the pop operation removes and returns the last inserted element in the stack. Stack auxiliary operations are top, return the last inserted element without removing it. Size, returns the number of elements in the stack. This empty stack indicates whether any elements are stored in the stack or not. Is full stack indicates whether a stack is full or not. There are some exceptions can occur when pushing elements to a full stack, assuming that the stack is array-based, and when doing pop operation on empty stack or retrieving the top element. Pushing element to a full-based array stack will raise stack overflow exception. Doing pop operation or retrieving top of the stack will raise stack underflow exception. Now we are going to talk about some of stack applications. We will divide them into two sections. First, direct applications such as infix to postfix conversion, evaluation of postfix expression, implementing function calls, including recursion, finding of spans, finding spans in stock markets, page visited history in a web browser, back buttons, undo sequence in a text editor, matching tags in HTML and XML, balancing symbols. Indirect applications such as tree traversal algorithms, simulating queues. Now suppose we want to push numbers from 1 to 4. We will assume variable name top that points at the top of the stack. First we will push number 1 to the stack, so the top is now pointing at 1. Then we will push the number 2 to the top of the stack, so now the variable top is pointing at 2. Now number 3 will be pushed to the top of stack, and the variable top is pointing at 3, and so on. Now, if we want to do a pop operation, we will decrement top variable, so the element under it will be the new top. Stack can be implemented in three ways: stack-based array, dynamic array, linked list. We will see their limitations and performance in the upcoming slides. Stack-based array. We use a normal array to store the stack values and use index to keep track of the top. Limitations: the maximum size of the stack must first be defined, and it cannot be changed. Trying to push element to a full stack caused implementation-specific exception. The following table shows stack-based array performance. Space complexity for n of elements is big O of n, whereas push and pop complexity is constant. The second approach to implement stack is using dynamic array. And it has two approaches. First we will discuss incrementing the size by 1. This approach says, when pushing element to a full stack, we create new array larger than the old array by 1, then copy all data from the old array to the new array. Problem with this approach is the way of incrementing the size of the array is expensive, because each time we push an element, we will create new array and copy data to it. So if we have n of push operations, the total time complexity will be big O of n squared. The second approach is repeat and doubling. Keep in mind, in dynamic array we assume that computer memory never ran out. In this approach, if the array is full, we create a new array twice larger than the old array and copy data to the new created array. At the end we add the element to the stack. In this approach we are doubling the array size in log time and n of push operations, so total time will be proportional to big O of n. Limitations of this approach is, too many doubling may cause memory overflow. The following table shows doubling approach performance. Linked list implementation is the preferable implementation of the stack. Linked list is a collection of dynamic allocated nodes, which points to the second node in the list. To make linked list work as stack, we push and pop from the front of the list. In the next video we will talk about using stack in real-time applications. Thanks for watching. Don't forget to like and subscribe for more programming videos.